Picture this. You wake up tomorrow morning, stretch, reach over for your phone, and absolutely nothing happens. The screen is black. You try to flick on the lights. Nothing. Welcome to This Explainer. Today we're diving into something that honestly feels like pure magic sometimes, but is actually incredible science. We're talking about electricity, that completely invisible force that literally drives our entire modern lives.
Seriously, I want you to really picture the immediate consequences here. It's kind of a terrifying thought, right? If this invisible magic suddenly vanished overnight, life as we know it wouldn't just slow down, it would hit an absolute brick wall.
Just think about what we would lose instantly. No fans, no AC, you can totally forget about charging your mobile phone, and definitely say goodbye to your Wi-Fi. No TV, no refrigerators to keep your food fresh, no water pumps, no elevators, no trains, and critically, no modern hospitals with working life-saving machines. Within just a few hours, our whole modern world would just stop. The stakes are incredibly high, which is exactly why understanding how this stuff works is so absolutely crucial for all of us.
You know, electricity powers absolutely everything around us, but we only ever see its effects, right? We see a bulb glowing or feel a heater getting hot. So what is it actually? Well, this simple definition really clears it up. Electricity is just the movement of tiny particles called electrons. That's it. Everything around us functions simply because these microscopic, invisible particles are moving from one place to another.
To really get this, we have to zoom way in and look at what everything in the universe is made of. Literally everything. Your own body, the desk you're at, your phone, it's all made of atoms, which contain these extremely tiny electrons. And here is the truly mind-blowing part. These electrons are already present inside every single object around you. The table, your chair, a piece of wire. They are absolutely packed with them. Millions of billions of them. Electricity isn't just magically created out of thin air. The electrons are already sitting right there inside a copper wire, just waiting to be pushed.
So that brings up a really crucial point. If they're already just sitting there in the everyday objects around us, how do these tiny electrons actually coordinate and move together to give us power?
Well, think of a crowded school corridor packed with hundreds of students standing in one giant long line. When a teacher yells, "Move," does only the very first student move? Of course not. Every single student starts moving at the exact same time, each one bumping into and pushing the person right in front of them. That is exactly what happens inside a wire. Electrons push one another in a chain reaction, and that creates an electric current almost instantly throughout the entire circuit.
Imagine two completely different roads. Copper is like this perfectly smooth, freshly paved highway. Electrons can just cruise through it incredibly easily. But plastic? Plastic is like a massive roadblock, completely covered in potholes. It behaves completely differently and refuses to let electrons move easily. We call that an insulator, and it safely traps the electricity inside the wire so we don't get a nasty shock when we touch our charging cables.
Now, who is actually pushing these electrons down that smooth copper highway? Imagine you've got two water tanks, one sitting on top of a steep hill and one way down below. As soon as you connect them with a pipe, water naturally rushes downward, right? A battery, or even a massive city power plant, does exactly the same thing. They don't magically create electrons, just like a pump doesn't create water. They simply provide the pushing force to move the free electrons that are already waiting inside the wire. So we know what electricity is and how it flows, but how does this invisible movement actually power the stuff in our homes? Let's break down a classic, old-school, incandescent light bulb. Think of it like a massive crowd of people trying to rush through a really narrow tunnel. First, electrons are forced into an extremely thin wire called a filament. Because it's so narrow, the filament heavily resists their movement. This creates massive friction, and the wire gets insanely hot. Eventually, it gets so incredibly hot that it actually starts glowing. And that, right there, is exactly how the bulb produces light.
But, a fan works completely differently. Electricity doesn't directly spin those blades. Instead, electricity enters the fan's motor, and that electrical energy is converted into really strong magnetic forces inside. It's those magnetic forces that physically rotate the motor, which then spins the blades so we can finally feel that nice, cool air.
Okay, here is a fascinating question that has probably puzzled every single one of us at some point while walking down the street. Why in the world don't birds get an electric shock when they sit directly on high-voltage power lines?
The secret is all about electrical potential. The bird is completely safe because it's only touching one single wire. Both of its little feet are sitting at almost the exact same electrical potential, so the current has absolutely zero reason to flow through the bird's body. It just bypasses them. But humans? We're basically giant bags of water and dissolved salts. We make excellent conductors. If we touch a live wire while we're also touching the ground, or another wire with a different potential, the electricity suddenly finds a brand new path to flow right through us. And that affects our muscles, our nerves, and even our heart. That is exactly why respecting electrical safety is so paramount.
You know, if we compare a water system directly to an electrical system, the translation is just spot on. The water tank, that acts as your power station. The water itself, those are the electrons. The pipe is your copper wire. The flow of the water is the electric current. The water pressure actually pushing it is the voltage. A narrow clogged pipe is resistance, just like that hot bulb filament we talked about. And the tap, that's simply your light switch. Honestly, once you see this comparison, complex electrical engineering becomes incredibly easy to visualize and wrap your head around.
Ultimately, those moving electrons are carrying energy, and our amazing modern devices simply act as translators, converting that energy into useful formats for us. A bulb turns it into light, a heater converts it to heat, the fan turns it into motion, a speaker to sound. And your smartphone? It's literally converting that exact same electron flow into thousands of incredible functions every single second.
It's really not magic, guys. It's science, and it's happening right now continuously in every single wire around you. So I'm going to leave you with this thought. Now that you actually understand this invisible force, what device in your room are you going to look at completely differently today? Thanks so much for joining me on this explainer, and keep exploring.